Good morning. Everyone hear me fine in the back? Yes? Everyone awake? Still sleeping? We good? Okay. You want to see?
Sure. So my name's Aaron. I work for Qualcomm on the cloud team. And today I'll be speaking with Bob about Qualcomm's use of Beanstalk. Excited to give you guys some more information.
Thank you. And I'm Bob Odell. I'm a principal product manager for Elastic Beanstalk. And I guess just to get started, for my sake of understanding, is how many in the room have used Elastic Beanstalk today? Well, not today, but just up till today. Good point. So about half. Okay, so hopefully everyone's in the right room, and I appreciate everyone both coming to reInvent as well as to the session here. What I really want to try to cover in the session is, what we see as some of the challenges of web application development. But more importantly, I want you to take away from this really how easy it is to run a web application on AWS using Elastic Beanstalk. Once we kind of get through some of that, I want to share some of the really core capabilities of Beanstalk and some of the more advanced features behind it. I want to show you how that can be easily integrated into a CI/CD type workflow. And then Aaron is going to share a very advanced use case of how Qualcomm took Beanstalk and integrated it into an application or a platform of their own. Before we jump in, though, I'd really like to share kind of what we hear as an all too common scenario today. So I'm sure a lot of you have probably heard this, is as a developer, or as a manager or a leader, basically you get handed a task. Let's develop a new web app or update or migrate an existing app really to respond to customer needs and competitive pressures. And there's always and make sure to list. And usually that's composed of things like, let's do it yesterday. We don't have a lot of time to do this. We have to react very quickly. By the way, we don't have any budget, so we've got to do it very cheap. You can't eliminate, or you have to try to eliminate as much downtime, especially if it's migrating an existing app or updating an existing app. And then the one big gotcha is make sure you adhere to all of our company standards. Make sure it fits in with our compliance and our governance. And then, by the way, make sure you keep everything else that you're doing up and running. And in most cases, what we hear is the list of make sure to actually takes longer than the development itself. So I was working with a customer just the other week who said, we had a project very similar to this. It took us about 5 weeks, so just over 2 sprints of ours, to basically develop this web app. It took us another 6 to 8 weeks to get the equipment, to get it racked, to get the security reviewed, to get all of the checklists done, and then to actually get it deployed. And by the way, it was highly over capacity. So on-premise in the data center, it was built for more than what it needed to be getting launched. So we hear that often, and we hear that a lot. So some of the challenges that scenario really represents is, from a business perspective, how can I do this with limited resources? And do this means things like load balancing, operations, auto-scaling, updates. How do I create health dashboards and monitoring? How can I make sure all of these have best practices built in and meet some of the standards that my company has set forth? Another business challenge that we hear a lot about is how can I accelerate innovation, but also allow developers to use different runtimes and different technology stacks. And from a business perspective, as the number of runtimes increase, so does the support and the security around those, and it becomes a critical factor at some point. A third business challenge that we hear quite often is how can we adopt a very systematic approach to CI/CD? And how can we make sure that both from a licensing perspective, from a maintenance perspective, and from a knowledge sharing perspective across teams that we're doing the right things? Now, the challenges from a developer perspective are a little different. They're how can I quickly deploy and test my application? And it's really about speed at that point. And I want that speed without having to learn a lot of new domain technology, without having to learn how to basically build infrastructure. I just want to focus and develop code. And then once I'm able to do that, I know that I have to meet some of those standards around governance and compliance. So how can I create a very simple but yet very robust CI/CD kind of workflow that automates a lot of that work for me, all the way from testing to building to deployment to staging? How can I do that in a way that doesn't slow what I want to do in development down? And then when we look at this across both the business and the developer, and we look at this kind of challenge both from our customers as well as from Amazon's experience internally, we see kind of two common challenges come up. And one is too much time is spent on things that don't deliver value for us. And the other is inevitably you always have to integrate that existing application in with existing infrastructure or existing applications, whether that's authorization, whether that's internal systems, whether that's databases. You always have to do that at some point. And so what I'd love to talk about next is really how can we run a web application on AWS, and what exactly does that mean? So if we put aside the how do I get it onto AWS and just look at the running aspect of an application, we kind of break it down into three really kind of key areas. And that is, how do I basically select what my infrastructure is? How do I provision that infrastructure? How do I configure it the way that I want to? Once I do that, then how do I deploy my code onto that infrastructure? And then last, once I have my code deployed, how do I ongoing manage and monitor that web application? Now, AWS itself has a lot of existing services that really enable you to do that. So if you look at our compute category, for instance, we've got EC2, we've got Lambda, we've got ECS, EKS, and Fargate. We've got services like Lightsail that help you basically have the compute power behind your applications. Storage with S3 and database with RDS and Aurora. Networking, we've got Elastic Load Balancing and VPCs. And then management tools, we've got a really robust set of management tools with auto-scaling, with CloudFormation, and with Systems Manager. And if you look at each of these services individually, they're very powerful services. But if you also think about running an application on AWS, each of these services, although very powerful, leave it up to you to learn how to use them and how to put them together in a way that you can run your application on. And then once it's there, it really leaves the configuration and the management up to you as well. And that's what Elastic Beanstalk does for you. Elastic Beanstalk is really the easiest way to get a web application up and running in literally minutes. No domain expertise, no knowledge of all of the underlying infrastructure. But Elastic Beanstalk is really a managed service that automatically handles that infrastructure provisioning and configuration. It handles the deployment, the load balancing, and the auto-scaling. And then it handles the health monitoring, not only during deployment, but ongoing as well. And then it even enables you, so if you do see something, you can get into a very deep level of analysis and debugging, and then you've got centralized logging. And the great thing about Elastic Beanstalk is the service itself is completely free. So there's no charge for Elastic Beanstalk. You only pay for the underlying resources that you consume through Beanstalk. So Elastic Beanstalk today supports some of the most common kind of runtimes as well as Docker images. And those runtimes are anything from .NET, .NET Core, to .NET Framework, to PHP, Java, We also support various application servers such as Tomcat, Ruby, Go, Node, Python. Most of the common languages are supported through Beanstalk today. A lot of those are built on Amazon Linux, and if you have, as a company, have standardized on a different flavor of Linux, for example, we also allow you to basically supply your own custom platform or custom image. So there's a lot of control that you have over that infrastructure and a lot of ways that you can tailor that to really meet your developers' needs. Now, what I'd like to do is really just show you how easy it is. It's one thing to say it, it's another thing to actually do it. So if we think back on specifically the developer challenge, how can I quickly deploy and test a web application? And with Beanstalk, you could do that in one of three ways. And I'm going to highlight the command line. That, for me, is actually the simplest, especially if I'm working on an application and I'm in my IDE or I'm on my machine. But you could also do these same steps through the console, or you could integrate it directly through the Elastic Beanstalk API. But we'll go through a scenario here where I've got an application. It's actually a Go application. And I'm going to basically deploy that application in three very simple steps. And in fact, it's actually 2 steps to deploy it and 1 step to commit a change. And using the command line, those are eb init, eb create, and eb deploy. And really what this requires is the prerequisite list is very small. So what this demo requires is, 1, I've got an AWS account. 2, I've got the right permissions within my account to be able to use Elastic Beanstalk. And then 3, I've got the AWS command line, or I've got a security configuration file with my credentials set up on my machine. And that's really it. And then Elastic Beanstalk has its own CLI called EB CLI. And you can get that from our doc pages or just from the downloads from Python. Okay, let's jump in here. So I've got my Go application here, very simple. I'm a product manager, so I had to keep this very, very simple. Basically, it's just putting it out to a web page. So I can go locally, I can see that, hey, I'm doing my testing, I'm doing my coding, I can run it, and you'll see it's just a very simple sample web application. So if I go to it on my local machine, it's going to come up and show me, congratulations, I created my first Go app. So now next step, how do I deploy that to AWS? First thing I'll do is I'll use the command line eb init. And this is an interactive command line. I could also script this, but I wanted to show the interactive mode. And the first thing we'll do here is select a region. Second thing we'll do is we'll define what our application's name is that we want to, as we want to see it in Elastic Beanstalk, and I'll talk a little bit about that. I select a platform next. So this is a Go application. And I then get to select which version of Go I want to run on my AWS infrastructure. I could choose to SSH into those instances once they're created. I chose not to. And now what I want to do is I basically want to deploy my application, and you do that through eb create, which again is going to walk through a couple very simple steps. Here's where I want to give it an environment name, and I'll share the difference between application and environment. I can choose to give it a C name if I want to use a custom C name, what type of load balancer I want to use. And again, these all have defaults built in. So if you don't know, it's very easy to just click through. And then basically, we're creating the application on AWS. Now, I fast-forwarded this a little bit, but if you're watching timestamps, you'll see this entire process only took about 3.5 minutes to complete. And typically, that's what we see is deploying an application through Beanstalk, especially in a development kind of testing mode, is usually between 2 to 3 minutes on average. And now I've got a fully running application in AWS on Elastic Beanstalk. If I go to the Elastic Beanstalk console, you can actually see there's my web application and there's my dev environment that I created to run that application in. So what happens if I want to make a code change? How easy is that then to go back into basically deploy that into AWS, into the application that I just created? And here I wanted to change the background color. So I can go ahead and go to my code, make that change locally. And to deploy that, it's basically, again, one command line. It's EB deploy. Now, because my infrastructure is already created, my application is already up and running, this step usually is anywhere between 30 to 60 seconds. So this is a very, very fast update to do. I can go back and refresh, and I can see that that change has now been deployed to my application on AWS. And if I dig in further to that development environment in Beanstalk and I look at what that looks like, you can actually see it shows you the event history there. So you can see with this particular one, I initially deployed it, and then I deployed a new version to those instances that were up and running. So you've got a full audit trail and a full history behind that, again, we'll talk a little bit more about. So very, very simple to do. And again, I could have done these same things by packaging my code up and deploying it through the console, or I could have used an API if I had a workflow that I wanted to already integrate that in. But very, very simple to do, and I didn't have to know anything about any of the underlying infrastructure that my application is running on. So if we look at what really just happened kind of behind the scenes, is we'll see that Beanstalk provisioned all of the infrastructure required, including the EC2 instances, the security groups that work between the resources, the load balancer, and in this case I chose an application load balancer, and then all of my auto-scaling groups. And more importantly, we manage the health behind that. So we set best practices, we set defaults, we know when to auto-scale based on a number of metrics around CPU, around memory, around latency. We do all of that work for you without you having to create some of those metrics yourself. We configured it with an Amazon Route 53 unique domain that you actually could define, but then you can map to that for your own custom domain on top of it. And then once that infrastructure was there, we basically took the operating system, we took the runtime that you supplied, we took the application or web server that was part of that platform, and we put your code on top of that, and then we safely deployed that onto that running infrastructure. Now, if you would have created this as, let's say, for instance, a Docker container, of course, you then would have done the runtime, the application server, and packaged it up, but exact same process. We would have deployed that on top of either EC2 or ECS directly for you. You basically just give us your image, we'll read it through the Docker file, and we'll do the deploys. So very, very similar mechanism, but works both ways. So if we jump into some of the kind of core capabilities of Elastic Beanstalk itself and some of the concepts that we just talked about, one of the first things that I really wanted to share is a concept of applications and environments. And this becomes really important when you think about staging. So an application can contain multiple environments. So if you think back to our Go sample, we created an application called Go Web Application. And then within that, we created an environment called Dev Environment. I could also create an environment called Staging, and I could create an environment further called Production. And all of those reside within kind of the logical web application that I created. So when you deploy your code, you actually deploy it directly to an environment. And what this allows us to do is really match different deployment types with different configurations. So for instance, I may have a dev environment where I'm really, my core concern is I want to test. I want to get it, speed is important. I want to deploy my application, I want to see it quickly, and then I want to be able to do some testing behind it. So there you may only need a single instance server, a small instance type, and you may want a deployment methodology that's very quick. But yet in my production environment, I don't want those same characteristics. I want to be able to have that a very safe deployment. I want it to be very high availability. I want it to basically make sure that I minimize any downtime or risk to a running application when I do a deployment. So that's how Elastic Beanstalk allows you to do that, is through the concept of applications and environments. We support two types of environments. So you can deploy a single instance or you can deploy it in high availability. And again, that may be a case where dev stage versus production stage. And then your deployment and health notifications, you can receive those through Amazon SNS or CloudWatch log streaming as well. So today, Elastic Beanstalk has support for both EC2 and ECS. So you can deploy directly to an EC2 instance, or you can provide basically a Docker image and run it either as a single image instance or a multi-container deployment. We've got a wide selection of EC2 instance types, so you can choose everything through micros up into really large GPUs, say P3s, for instance. And then we support all three load balancer types. An important aspect, unlike maybe a traditional PaaS, is you own all of the resources underlying this. So when we create and provision those, we do that within your AWS account, which also gives you a very high level of control behind that. And in order to interact with those resources, we provided a mechanism called EB extensions, which are basically just a set of configuration files. But with an EB extension, you really, and you can find these on GitHub. If you go to the AWS Elastic Beanstalk samples, you'll see a lot of EB extension samples out there. And think of them as things where I could basically configure my instances to work with WebSockets. So if I didn't want to do a standard web server, I wanted a WebSocket type of implementation, I could use an EB extension to enable that. And I could do it through managing it as code. Now a tip with that is I would always recommend deploying an EB extension kind of testing in a new environment, because if you don't get those quite right, you do own those instances and you could really mess it up and disable it. So test it first, and then deploy it as part of your code package. But you've got full control over all of the underlying resources and can tweak those as much as you need to. The other thing that Beanstalk provides, because of the way we manage applications and environments, is we also manage outside of code what we call application versions. So every time you do a deployment, you create a unique application version. And these are stored within your Amazon S3 account as very unique deployments. And if you think about, there's a couple use cases of what this allows you to do. Is, so for instance, if you've got a small team, everybody's committing code changes, you do a deployment to Beanstalk and something's not working. Instead of basically extending any potential impact or downtime associated with that, you could instantly roll back to the last known working version through an Elastic Beanstalk application version. You didn't have to change anything on your source code. You have time to figure it out, but yet your application can be reverted back to a last known good state. The other thing that application versions really allow you to do is if you want to do promotion. So if I'm testing in my development environment and it passed all of my tests and I want to then move that same version that exists to a staging environment, I could do that through an application version. Very easy to select what version you want to be running on each of the environments within kind of your application structure. One of the other really big benefits of Elastic Beanstalk is health monitoring. And health monitoring is done both through deployments as well as through ongoing. And what health monitoring is it really consists of checks around your load balancer, around your resource metrics, around your OS metrics, as well as your web server or application server logs. So again, instead of you having to do that yourself and set those up and define those and gather those, Elastic Beanstalk does that for you. And we make determinations based on those different gathered resources on what the state of your application is. So we've got various states ranging all the way from okay to unknown, all the way to degraded or severe. And it's based off of all of those metrics that we gather. We also enable you to, we give you the capability to easily enable X-ray. So with X-ray, you can do traces, you can do debugging, you can really get to a granular level of where an issue may reside. And these are all visible through the console. In the Elastic Beanstalk console, we have a health overview, as well as through CloudWatch logs. And then you could also use the CLI or API for easy integration of these health metrics and monitoring into an existing system or workflow that you have. Elastic Beanstalk also has a very focused security and compliance aspect to it. So one of the things that we provide is what we call managed updates. And managed updates could be both patch versions as well as minor versions. So for instance, in my Go application, I may want to have that automatically patched for any of the underlying OS patches that come out. Or I may want that automatically upgraded to any minor versions of Go that are available. And Elastic Beanstalk will do that in a very visible way for you. And if we detect that your application doesn't work with those, we'll automatically roll that back. So we won't ever leave the application in a degraded state. And we'll notify you that your application wasn't able to be upgraded so that you can then further troubleshoot why. We also integrate directly with IAM for instance profiles as well as service roles. So again, because you own the resources, you have a very high level of control of who can access those, what other resources, the Beanstalk resources that were created can access, and you can do that through very common ways with IAM today. And then everything is auditable. So we integrate directly with CloudTrail. You can see who's making changes, what's occurring to your applications and your environments, what Beanstalk commands are being run and by whom. And then we also integrate with config. So if you have a company standard around what an application could look like, you could set that up in config and instantly be notified when something steps outside of those bounds. So one of the other challenges that we talked about at the start was really how do I extend to a CI/CD kind of DevOps workflow? And the way that we can do that, there's multiple ways, but one of the easiest ways we can do that with Elastic Beanstalk is by integration with our Code Suite services. And our Code Suite services are things like AWS Code Commit, Code Pipeline, and Code Build that have native integrations with Elastic Beanstalk. If we look at each one of those, and each of these are actually a reInvent topic in themselves, but just at a very high level, Code Commit is a fully managed Git service. So if you're used to pushing into GitHub or another Git service, this will be very, very familiar for you and directly integrated with Elastic Beanstalk. Code Build is a fully managed build service for compiling source code, for running unit testing, and basically for producing software packages that can then be deployed through AWS Code Pipeline. And that's a continuous deployment service for basically really fast and reliable updates. Now, the great thing about AWS services is they're plug and play. So another challenge is I've already got some existing infrastructure around DevOps or CI/CD, and how can I leverage that? These really are interchangeable. So Elastic Beanstalk could work just as easy with the Code Suite services on the previous slide, as they could with existing technologies that you may have today. So if you've got a GitHub repo, whether that's .com or an enterprise, if you're using Jenkins as your pipeline, you could still use something like the code build plugin to Jenkins and deploy directly into an Elastic Beanstalk environment. So regardless of what type of deployment tool chain you have, you can still leverage the operational and ongoing management strengths of Elastic Beanstalk itself. And then finally, for customers that want to even take that a step further, whether you're a customer or you're a partner and you want a deeper level of integration, all of these services can be consumed through a set of public APIs. So everything that we work with, from code commit to code build to code pipeline, they're using the exact same Elastic Beanstalk APIs that are available for you today. And what this really allows is customers and partners to build their own application platforms on top of Beanstalk that still really leverage the experience of the scale and the breadth of services provided by AWS. And the second part of this talk, Aaron's going to provide for us as a customer in Qualcomm that did exactly that. They took a very advanced use case and basically built it out on top of the Beanstalk APIs.
Great. Thanks, Bob. So who or what is Qualcomm for who aren't familiar? We're the #1 fabless semiconductor company, #1 in 3G and 4G modem technology, now developing 5G. So we're helping innovate in the wireless and now the IoT space. And so kind of why did Qualcomm make the decision to go to cloud? So for those who aren't familiar, Qualcomm is basically a very large engineering company. And so while we do have an IT presence, that's a small portion of it. But basically, we reach a certain point where you can't just continue to buy millions of dollars of hardware and continue to grow. So how do we begin to scale? So we wanted to look at things, how do we look at taking advantage of the breadth of services that we weren't able to previously? How do we look at things where instead of having to have huge upfront CapEx models, how do we do things that are utility-based, where as we use things, we get charged for it, and when we decide we're done with it or it's a proof of concept, we just turn it off and there's no more cost to be incurred for that. So those were very large reasons for us. A lot of the managed services that AWS had on, even early on a few years ago when we began our journey for the cloud, meant that instead of having to manually stand up these services and maintain the software and the configurations, a lot of those things were made significantly easier by Amazon. And lastly, it gave us a really quick time to market. So again, instead of having to do hardware purchases, procurement, a lot of these things that take up time, you need something in the cloud, click a button, and it's there. So why AWS? Like I mentioned, the breadth of services and capabilities, and obviously, as you've all been watching this week, and I don't know, they probably had 30 announcements since we got here. Well, some of us got here Monday. I mean, they just continue to innovate quickly. So it's really great for people who are looking to continue to be, at the leading edge, or just looking for how do I work with a platform that's going to continue to grow as my company grows. And then as a part of that, the unmatched scalability and reliability. I forget the exact number, maybe Bob remembers, but Amazon's bigger than like the next 3 top cloud providers combined. So they definitely have the market share to prove their growth and show their innovation. And then for us specifically, we utilize enterprise support. And so that was a big part of the decision for us, is we wanted to know that as we use a cloud provider, when we build on top of their services and their capabilities, that we get that direct support from them. So how did we go about our adoption of cloud at Qualcomm? Qualcomm's cloud journey, so to speak, began about 5 years ago. And it was kind of slow. The first 2 years were really exploratory to see what can we do, what does cloud offer. But the last 3 years, we've really made a lot bigger growth there. And with that, we started to learn, what are kind of the pain points of going to the cloud? How do we make sure that the environments are secure? We've figured out how to do that on-premise, but how do we make sure that we can build those same capabilities for security in the cloud as well? Next, how do we look at building HA environments? So, we can build HA, but for someone who's perhaps new to AWS or just new to cloud technologies, you can also do that incorrectly and it gets expensive very quickly. Saying you want to scale to 1,000 nodes potentially for a very large service and then accidentally scaling all the time means your bill is significantly larger than you expected it to be. Next, my team is the cloud team. There's about 8 of us, and we kind of serve as a center of excellence for cloud at Qualcomm. Qualcomm has 30,000 employees, If you can do quick and simple math, that doesn't scale infinitely very quickly. So we kind of had to figure out how do we best support the company in the cloud journey that we're making. As we continue through our cloud journey, we discovered, there's a lot of things that you have to take into consideration. Qualcomm has notoriously been very good at managing data centers and doing things in-house. But when you go to the cloud, there's a lot of things that you have to think about differently. Architecture, security, just the general mindset of the tools that the cloud offers, specifically AWS. You kind of have to reevaluate how you're going to utilize all those things. And so as a part of that, we had some learning curves. And some of that was, if we take some of the user element out of using the cloud, we can help developers and operations teams utilize the cloud more easily. And basically, that's what led us to our solution Forge, which I'll lead into in the next couple of slides. So Forge was the solution that Qualcomm decided to build and builds on top of Beanstalk. So I'll kind of highlight a lot of what Bob's talked about and build on how we specifically took advantage of those capabilities within the Beanstalk service offering. So the first thing we wanted to look at is how do we make sure that everything we do is fully automated, we don't have to mess with manual configurations, and then as a part of that, how do we orchestrate the best practices that AWS recommends as part of their blogs they put together in terms of shared security models and other responsibilities as a cloud user, and then make sure that we're also following the best practices that Qualcomm puts together. And last but not least, and as Bob mentioned, how do we get web applications out to users and developers and operations teams quickly, literally within minutes, so that way they can continue working, continue to develop and innovate. As a part of that, Bob touched on looking at how do we make incremental changes to our applications. So if I'm making a small configuration, I don't want to have to go rebuild everything. I need to be able to innovate quickly and iterate on my changes that developers are making. And then when things do go wrong, how do we take that and handle those rollbacks or the management of making sure that just because a bad change was committed or when Bob was talking about the platform updates, how do we make sure that if something goes wrong, this doesn't all just fall on the floor and now we have a broken application and someone has to go figure out why. Making that graceful is one of the great things that Beanstalk has done and why we chose to build on top of the platform itself. I'll touch on security a little bit later, but that was one of the big things we wanted to keep in mind. And then as I touched on, how do we kind of abstract away the cloud? Not that using AWS is difficult, but there's definitely some learning curve, and that learning curve differs for each and every person. So if we can kind of take away some of that element of, I need to learn how to use EC2, and then I need to know how to integrate it with load balancers. And then when I get to the point of using Beanstalk, how do I tie all these things together? We wanted to make it seem very seamless to the user and not necessarily have to understand the complexities that come from linking all these services and the integrations that they involve together for them. And last, how do we build CI/CD into this offering? We want to make sure that teams who are familiar with CI/CD can continue to utilize those tools, but also groups who don't have any experience into tools like Jenkins or the various DevOps tools that you see common for CI/CD pipeline work, that we can enable them to utilize those technologies as well without having to necessarily understand how to implement those tools and then how to utilize them fully. So we'll take a quick glance at Forge and kind of what brought us to this point. So I mentioned large organization, 8 people are not going to be able to handhold or work individually, face-to-face with all of those 30,000 people to make sure that each use case gets guided time into the cloud. It just doesn't scale, at least until somebody figures out a way to get more than 24 hours out of a day. So with that, how do we provide a robust solution that touches and makes use of CI/CD? And again, security, a big thing, and we'll touch on that a little bit later. And most importantly, not just for the end users, our customers utilizing Forge, but for my team as well, how do we make it easy? We wanted to go from having very large time investments for complex architectures to still making that same use case very simple for those larger use cases. We encounter a lot of the same problems that Bob touched on. So one of the common things that we get is, how much is AWS going to cost me to use? And for anyone who's used AWS long enough, that answer is yes, it will cost you. How much it will cost you and how you break that down can become very difficult. And so we wanted to make that a little bit more transparent to the user. And I'll touch on that a little bit later and show you some examples. The other big thing we ran into problem-wise is there's a lot of enterprise services that Qualcomm offers for the various application developer teams. How do we integrate those into Forge as a solution? And as always, adherence to best practices. So what we found is basically when someone comes to us and says, hey, I have an application, I want to take it to the cloud. That initial kind of engagement with that group can be a simple 1-hour meeting sometimes, and they know enough about AWS already that they can kind of get going and keep working on their own. or there are times where they don't have much experience with AWS. It's a large use case, and we can spend weeks to sometimes months with some of these teams helping them make their journey into the cloud utilizing AWS. So obviously that weeks to months time period doesn't scale, and that's where the time and people resource becomes an issue. So we found, as a result of utilizing Forge, we've taken application teams who've had that same question: how do I get my app into the cloud? And instead of spending weeks or months, in a single business week or less, we've gotten their application deployed and running fully in an HA prod environment for them, and they're ready to go. And there's not as much of that time learning the services and understanding how that all works. When we put Forge together, we wanted to make sure that we're not reinventing the wheel, so to speak. We don't want to build everything from scratch. That's a maintenance overhead for us. We don't want to incur a lot of technical debt. So how do we do this in a much better and more efficient service, or more efficient fashion? And so we used AWS services natively. Again, touching on what Bob was mentioning, we make heavy use of VB extensions for allowing users to customize their environment within Beanstalk and do some other fancy things that we'll touch on as part of the Forge-specific platform itself. So in terms of helping still solve the overall problem of cloud, one of the common things we see is people inevitably spin up their EC2 instances. They're manually managed. Someone needs to make a change that gets pushed to production, so how do they do it? They go SSH into every instance and push that change, except for that one instance they forgot about or they made a typo on. So how do we get rid of infrastructure drift? So that was a big problem that we helped to solve as a part of Forge. Basically, underneath the hood, and I'll show a little bit later, we're actually using CloudFormation to build all of the Beanstalk environments and the configuration, which means that we have a known repeatable pattern that deploys these applications over and over and over again. So that means that worst case scenario, if someone goes in and makes a manual change, we can revert back, and there are ways to prevent that infrastructure drift. And again, just how do we get those services for the enterprise, like single sign-on, DNS logging? How do we make all those things really easy for the user instead of having to understand a spaghetti of this integration goes here and make sure you check these 3 boxes and make sure that you get everything else configured? So at its core, Forge is really just an orchestration platform. We take a bunch of templates that are pre-built in CloudFormation, we define those, and then CloudFormation deploys those for us, builds the Beanstalk environment, and then for the user's perspective, really what they're getting and their only real entry point into the Forge environment, other than a web UI for selecting how they configure their environment, is pushing their code. So we make heavy use of the developer tool sets, code pipeline, code commit, code build, and the native integration for all of those services with Beanstalk means that we can make developer integrations and their deployments into the Beanstalk environments on top of Forge really, really simple. Again, not all teams had experience, and so the use of these tools and their integration into Beanstalk is what helps make Forge such a success and extend those capabilities to teams whether or not they have the knowledge. So security. As we started building Forge, our security team was very focused on, well, how do you make sure that this isn't going to result in the same sort of configurations we see for people who build things by hand. So inevitably, someone will create a security group ingress for SSH open to the world. That's not great. That presents problems. So how do we make sure that we can solve those types of things? So all the source code is encrypted from point to point. There's nowhere that anything at rest or in transit is unencrypted. So there's a lot of peace of mind for our security team there. And then in terms of building more security boundaries, we put each application into its own account. Caveat to that being, we understand there are some applications that are composed of multiple microservices, or maybe you have 2 development teams, you have a web front end and you have a back end development team. And those are 2 logically separate components of a single application, and so in that case, we do allow more than one application to be deployed. But then even within that single AWS account, taking the example, let's say you have an Angular front end and a Python back end. Your Angular application as a front end gets deployed into its logically owned non-routable VPC, and then the Python back end as well also gets deployed into its own non-routable VPC. We allow for linking, and I'll show some examples of that later. Basically, we're making use of VPC peering between those non-routable VPCs to create a routable route between those. It's an awkward phrase, but basically, how do we take those microservices and then, or the multiple components of an application and allow users to still deploy the same way they would expect to? In terms of common things, we also see people inevitably from time to time can commit secrets into their version control system. Bad practice, don't do that. But we also see them writing things out to disk. And so even if they're not committing it to source control, when it actually gets deployed onto the server, you actually have secret or sensitive information on disk. And we wanted to help prevent that. So we tie in heavily with parameter store. And through the use of the EB extensions, we actually are able to then give the users the capability to dynamically inject all these application secrets into their application at runtime. So nothing's ever written to disk. Making for a really great secure integration because parameter store integrates with KMS, which means that everything's encrypted at rest. And we're tying into CloudFormation again, helping prevent drift. So all these things were a lot of things that we took into consideration. And for right now, everything we build on Forge is only limited to intranet access. We're working on external, but the goal here was how do we help enable the enterprise to build things securely, and that was one aspect that helped there. So we'll take a look at what is Forge, what does it look like, what do our users see, how do they kind of get started. So you can see here there's actually a couple of other options outside of just deploying a web app. Forge does more than just build on Beanstalk, but Beanstalk is a heavy component of this. So other use cases supported, but basically they choose from our landing page, what do you want to create? Once they go there, we collect a little bit of metadata. Some of this is for governance and compliance for us, kind of determining some environment information, like what's the application name, so we tie stuff into CMDB. We want to know what type of environment, is it development, production, so on and so forth. And this is other metadata that helps the user if you're deploying multiple applications or environment types. Above and beyond that, then we start going to configuration. So this is where we start to get into more of the complete abstraction away from them understanding that there is actually Beanstalk underneath the hood. And this isn't to say in order to use Beanstalk, you have to go this route. We chose to take a very abstracted approach because we found that that was what was going to best engage our users and our specific enterprise. But that's not to say you have to build something like Forge to utilize Beanstalk. You can definitely go and use methods like Bob talked about, use the CLI, use the APIs, use CloudFormation to define everything. You're still going to get great results from a service that's incredibly resilient, and helps make their developer and operations lives much easier than building things by hand. So part of that is we wanted to simplify things, pick CPU and RAM footprint. So we don't offer every particular instance type that's available because that would be overwhelming, but we want to provide some basic configurations that they're used to seeing. Coming up with things like, same things for databases. So what engine flavor do you want? Are you using MySQL, are you using Postgres, are you using Aurora? And then big, medium, or small, medium, and large for database types. Once they pick this, they get some configurations that are actually showing for them and kind of change on the screen. And so part of this is helping to answer the question of how much is this costing me? So this isn't an exact, it will cost you N number of dollars a month, but we give them an estimate so as they make these choices and say, I want a medium-sized EC2 instance or I want a large database, we actually update a dynamic costing panel in our UI for them, and as they change these configuration options, they can see how that affects their running monthly cost and gives them some better insight into how much the Forge environment they deploy will cost them. For users who are deploying multiple applications, we have insight into showing, what is everything that's running in their account or accounts if they have multiple, giving them a quick access to see all of the Beanstalk applications they've created. Clicking into applications, we're basically taking a lot of the metadata that Beanstalk exposes, the configurations for what type of EC2 instances they pick, what region is it deployed into, exposing these out to the user and then giving them that cost summary again, so that way, as they've made changes or configuration tweaks, this information is always readily present and transparent to the user so they know what's happening. So secrets. I mentioned we make use of parameter store. So users get access to this. Everything, again, is encrypted at rest. They can then make use of these through EB extensions and take these secrets that they need to specify for their application, API secrets, usernames, passwords, whatever it may be, sensitive information. And all this gets dynamically injected into the Beanstalk environment for them and means that they don't actually have to mess with how do I store my secrets. So in the use case where you have applications that need to talk to each other, again, these VPCs are intranet only and they're non-routable. So we wanted to give them capabilities where maybe you have multiple applications that talk to each other or dependencies on each other. So we put together in what we call linking. It's really just VPC peering underneath the hood. And this gives you the capabilities to link multiple applications together that need to make dependency calls or just talk to other services for other information. So as Bob mentioned, one of the great things about Beanstalk is you have all these things like your EC2 instances, your load balancers, access to logs. But typically, if you're building an application just raw on top of EC2, configuring your load balancer, even if you do this in an automated fashion and you've got your CloudWatch Logs agent, you stream all your logs to CloudWatch Logs, if you don't already have some sort of centralized logging in place that helps for log aggregation and more of a centralized view for debugging, there's no quick and easy way to get access to all those things from a single pane of glass. But Beanstalk actually enables that. And so whether you're doing it via APIs or directly in the Beanstalk console, you can actually go take your deployed application, all the logs from that instance, whether in a tailed format, and it'll give you the last 100 lines of everything, or say, I want all the logs, and it'll just give you a huge bundle. You can actually do all of that directly through Beanstalk. So you're not actually going from one service to the next to try and go troubleshoot things. It really helps with making that seamless integration and use of a service kind of the developer and operations dream. And Beanstalk has done that very well. And as a part of that, we take that and then we expose to the Beanstalk APIs those logs to the users. So if a user deploys a bad configuration, there can be use cases where if you deploy bad code, like Beanstalk will potentially deploy that code, and maybe your route isn't accessible to an API method in your application. So developers and operators need to know, okay, what's happening with that? So we give them quick access to deploy, to download those logs directly through Forge, again, making use of Beanstalk. And then that bottom section that you're seeing is what Bob showed for the console events. So as the Beanstalk environment makes configuration tweaks, or if you wind up where things are in a degraded or severe or unknown state, we give all of that information that we're pulling out of the Beanstalk APIs back to the user in the UI format in Forge. Again, they don't need to know how to go find it in the Beanstalk console, so we're making heavy use of the APIs to expose that information in an abstracted way for them. So kind of tying all this together, our goal was, how do we make this easy? So common use cases are web applications. Beanstalk allows us to do this very easily, very quickly, in a very robust manner and make things secure. Then it allows us to continue to adhere to Amazon's best practices as well as Qualcomm's. And then it's really helped us with our adoption. So we were able to go from these really large engagements taking a lot of time to basically now we can take 2 or 3 days and we have users with applications. And with that, I'll turn it back over to Bob.
Great, thanks, Aaron. So just to wrap up our session here, hopefully if we think about like the common scenario that we talked about, some of the challenges at the beginning, hopefully what you guys have been able to see is just really how easy it is to launch an application, a web application on AWS using Elastic Beanstalk. And with that, there's no need to learn any of the underlying services, no need to worry about the provisioning, really just simple to do. And again, think of the Go sample or the Go demo that we did. Within 3 to 5 minutes, you can have a fully running application up there. So you can do it all the way from development through a fully managed production stage. And really what that gets to is kind of those common challenges, is Beanstalk really helps you spend your time where it matters most, and that's developing your code and solving business problems. So hopefully everyone was able to see a little bit about that. We've got some related breakout sessions here, so a couple of our engineering managers actually later today and tomorrow are doing advanced deployments, blue-green deployments using Elastic Beanstalk and how you can easily do that and what the different deployment mechanisms look like. And then if you're interested in DevOps, serverless, containers, or building microservices architectures, we've also got a session on Thursday that features the GMs of those businesses and should be really, really interesting as well. So I think it was a late added session. There's probably some seats left. But if you've got an opportunity and interested in that, take a look at that as well. But with that, I would really like to thank everyone for coming this morning. Again, I'm Bob O'Dell. And
Aaron Bauer, if you have questions, feel free to come to us afterwards.
Yep.
You can find me on Twitter or you go online. I have a website. You can shoot me an email, dadops.cloud. Feel free to reach out. Happy to help answer anything I can.
So we'll go ahead and end the session, but myself and Aaron will stick around. If anyone's got some questions, we'd be happy to help while we've got a few minutes here left in the room. So thank you, everyone.
Yep.